Hi everyone. Today we'll look into quick DSA revision or 20 problems cheat sheet. So I will explain the whiteboard. So most developers try to memorize hundreds of coding interview problems, but the truth is that most of them come from just a few patterns. In this video, I will show you a quick DSA revision cheat sheet that helps you recognize these patterns instantly. So instead of 200 plus LeetCode problems, we'll just look into 15 core patterns. Correct? So what we will do, instead of memorizing solutions, we focus on three things. One is problem, second is our pattern, and third is trick or technique. Correct? So I will explain few of them today, and I will give you the image or PDF for the all other 20 patterns. So let's start with do sum. Correct? So do sum uses HashMap pattern. So trick is here our target minus current number. So other next one is select, for example, three sum. Pattern we use is two pointer approach, and trick we use sort first approach. So third one is substring. Our pattern would be here sliding window, and trick would be expand or shrink. Correct? So fourth problem would be top k element. Here our pattern we use is heap, and trick would be a frequency. And last, which I'm going to explain, is island problems. So here we use DFS and BFS, and trick is mark visited nodes. So as I said, instead of memorizing solutions, we focus on three things: problem, pattern, and trick. Correct? Now first I will go to the our two sum problem. So in this two sum problem, we are using pattern HashMap. Correct? And trick is target minus number, that should be current number. In the two sum problem, we store numbers in HashMap for every element, and we check if target minus current number already exists in the HashMap. This reduces our time complexity from O of n square to O of n. Correct? So next we have a duplicate detection. So here we actually, our problem is contains duplicate, and pattern is hash set. Correct. If we need to detect duplicates, the fastest solution usually a hash set. When inserting elements, if the element already exists in the set, we know there is a duplicate. So here we can use hash set. Correct. So next I would explain two-pointer approach, two-pointer pattern. Here, for example, our problem is 3 sum, and in this case we use pattern. First is we sort, then we apply two-pointer approach. This is the trick. Correct. Next I would say sliding window pattern. And this problem would be a longest substring, and pattern we use to solve this problem is sliding window. Trick we follow here is expand right side, expand right, and shrink left. This we can easily remember, right? So in the sliding window is commonly used in substring problems. We expand the window to the right, and if the condition breaks, we shrink the window from the left. So substring equal to, we can use sliding window. We can remember this thing. So next I would say heap pattern. So in the heap pattern, the problem is finding the top k elements, top k frequent element, I would say. Correct. So pattern we use is heap here. When a problem asks for top k elements, the best solution usually involves a heap or priority queue. Correct. So I will show priority queue. So here we maintain a heap of size k to track the most frequent elements. So I would say our memorizing or memory trick is top k equals to heap. Next is graph traversal pattern. Here we can our problem would be a number of island problem, and pattern would be DFS, breadth first search, or breadth first search. Correct. In the grid or graph problems usually require DFS or BFS traversal. So we explore connected components and mark visited cells to avoid repeating work. So whenever there is a grid or graph problem, just remember that grid or graph is equal to DFS or BFS. Correct. Next we can see a binary search pattern. In the binary search problem, we usually we use pattern called divide search space. Correct. So our problem is binary search and pattern would be divide search space. In the binary search works when the array is sorted. At every step we check the middle element and eliminate half of the search space. So here thing to remember is sorted array equals to binary search. Correct. So this is the memory trick we can use or remember. Next I would take tree traversal. So here tree depth problems are typically solved using DFS recursion. So how the depth is calculated as, so that is the trick we can follow. So I would say the problem is max depth tree and our pattern is DFS. And how the depth is calculated? So here depth equal to 1 plus max of, we need to implement this logic if the language doesn't support the max method. So this is the thing to remember. So next we go through dynamic programming pattern. Or DP pattern. Correct. Usually we know the problem, climbing stairs. So pattern is Fibonacci dynamic programming. In the dynamic programming is used when problems have overlapping subproblems. Examples: f of n equal to f of n minus 1 plus f of n minus 2. Correct. So these are the techniques we can use to or patterns to solve the DSA problems. So instead of going through all the 200 problems, so easily you can remember these patterns and solve the most coding interview problems quickly. Correct. So let me show the entire set of patterns here. So here we have a 2 sum contains duplicate, 3 sum longest substring, container with water. So you can go to, we have a listed problem, pattern, trick. and when to use, trick, pattern, problem. Yeah, and these are the number of problems displayed here. So instead of 200 problems memorizing, we just focus on the recognizing the patterns behind the problem. So if you are going for any interview, just go through this sheet for a quick revision. That would be very helpful to, yeah, recognize the pattern. Yeah, if anyone needs this sheet or a image, can just ping me your email ID in the comments, so I would share this, yeah, document with you guys. Yeah, thank you.